The objective of this topic is to provide a basic understanding of the various types of pipe weld joints associated with the gas tungsten arc welding process.
The gas tungsten arc process is normally used for welding pipe where high-quality welds are required, such as welds on high-pressure piping. High-pressure piping can be found in thermal and nuclear power generating stations, refineries, chemical plants, and other related facilities. Tubing is also used in these facilities, and although there are differences, the joint designs are similar for pipe and tubing.
The type of base metal has an effect on the joint design. For example, steel pipe joints differ from those of aluminum pipe due to thermal conductivity, melting point, and other physical differences. We will confine our discussions here to steel pipe, which makes up the majority of pipe welding.
Other factors which affect the joint design are the accessibility of the joint, the required strength, and the position of the joint.
In most cases, the pipe joint is only accessible from one side, the outside of the pipe. On large diameter pipe, welds are sometimes deposited on both sides of the joint.
The amount of joint penetration is an important factor in determining the strength of a weld. Pipe welding, especially in critical applications, requires complete penetration of the weld. The joint must be designed to allow for full weld penetration.
Pipe joints may be located in many different positions. Because of this, pipe joint designs must be suited for welding in all positions. The 5G or 6G positions simulate many or all of these.
The joint designs for gas tungsten arc welding of pipe are especially affected by wall thickness. On thin wall thickness pipe, the edges of the joint are normally prepared as square groove joints.
Cleaning, filing, or some grinding may be needed to remove contaminants or burrs from the weld area to provide a consistent root face.
On pipe wall thicknesses of 1/16 inch or less, the edges of the joint are placed together with a zero root opening. In some cases, filler metal is not used, and the edges are welded together autogenously.
As the wall thicknesses increase above 1/8 inch, both edges of the joint are beveled. A single V-groove weld is produced in these joints. The addition of the bevels provides better accessibility to the root of the joint. The groove angle is normally 75 degrees, which is made by preparing each edge with a 37½ degree bevel. The root opening is normally 3/32 to 1/8 inch in width.
For wall thicknesses greater than 3/4 of an inch, a modified V-groove is sometimes used in order to reduce the amount of filler metal required and decrease the welding time. A bevel angle of 37½ degrees is produced on the joint edge up to 3/4 of an inch. The remaining pipe wall is prepared with a 10-degree bevel angle.
In some cases, a radius is placed on the edges of thicker members to be joined. This is commonly called a single U-groove weld. The U-groove provides better accessibility to the root, while reducing the rate of filler metal consumption and welding time, as compared to single V-groove welds. The cost of preparation, however, is higher on these types of joints, since the edges normally have to be prepared by machining.
Prepared joints are normally used in conjunction with a consumable insert. A consumable insert is a preformed filler metal, which is tacked at the root of the joint and is completely fused into the root during welding. Consumable inserts are used to assure complete uniform joint penetration and root reinforcement. They are also used in confined areas where welding with a filler wire might be difficult.
There are several types of consumable inserts. One of the most common is the A or EB type, which forms a ledge for both edges of the joint. The J insert is similar to the A, except that one side is flat and can allow for a certain amount of joint misalignment. Both the J and A inserts are available in coils, preformed rings with an overlap, or split-butted to allow for variations of the inside diameter of the pipe.
The K-type insert, sometimes called a Grinnell ring, is produced by rolling wire into a flattened rectangular shape. It too is available in similar forms as the inserts already mentioned.
Rings having a diameter up to 2 inches are not prepared with an overlap. Inserts over 2 inches in diameter are prepared with some extra diameter to allow for variations in the inside diameters of the pipe. The overlap can be cut off with a saw or hand shears.
When a K or Grinnell type insert is used, the insert is sometimes allowed to extend above the root edge in the flat portion of the pipe and below the root edge in the overhead portion. This procedure compensates for sagging of the molten metal due to gravity.
When welding with automatic gas tungsten arc equipment, an extended land is commonly used with a zero root opening. In this manner, the root pass can be produced without the addition of filler metal.
At times, it may be necessary to weld 2 pipe sections with different wall thicknesses. In this case, a specialized kind of joint called a transition joint is normally prepared. The thicker of the 2 members is machined down to match the thickness of the thinner member before reaching the joint edge.
Usually, thinner materials or small diameter pipe and tubes are welded with the gas tungsten arc process alone. However, on larger wall thicknesses and larger diameter pipe, only the first and possibly the second passes are deposited with gas tungsten arc. The remaining passes are deposited with a higher deposition process, most commonly the shielded metal arc or the flux cord arc welding process. The type of joint design, type of material, and the method of welding the joint all depend on the specifications as noted on the welding procedure.